Okay, we're going to start talking about tangent lines today. So something that's really important with tangent lines, because you're creating a 90-degree angle here, Pythagorean theorem will really come in handy here. So a tangent line, if you remember the definition, it intersects a circle at exactly one point, and it is called the point of tangency. So the point here of tangency is point A, okay? So a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if you look here in the picture, this radius that is drawn is AP, and it is perpendicular to this tangent line. Okay, so it creates a 90-degree angle. So in the next couple of problems, our directions state to determine if AB is tangent to the circle P. So what we want to prove here is that it creates a 90-degree angle. And in order to do that, we have to check and we have to make sure that Pythagorean theorem works. We want to prove that there's a 90-degree angle here at the point of tangency at A. So in that case, this would make this segment C, and this could be A, and this could be B. So we're going to set up Pythagorean theorem. Remember, A squared plus B squared equals C squared. Okay? So we're going to plug in. I'm going to have 8 squared plus 15 squared equals 17 squared. So I'm just going to plug in the left side into my calculator. I'm going to have 8 squared plus 15 squared. I'm going to get 289. And then I'm going to plug in the right hand side. I'm going to plug in 17 squared. And that gives me 289. So what that tells me is that this is a right triangle because Pythagorean theorem works. So yes is your answer. AB is tangent to the circle. So we're going to do the same on number 2. So on number 2, I should have a 90-degree angle here at A, but we want to prove that. So the side C would be BP, and then A and B can be the other two in whatever order. Now there is one piece of information that I'm missing. I'm missing this segment right in here. I don't know what that length is. But in my circle, this segment is actually a radius. And so is this segment. So they should be the same. This should be 11. So total 5 plus 11 should make the total side here 16. And now I have enough information to plug in. So I'm going to take 14 squared plus 11 squared and set it equal to 16 squared. So in your calculator, 14 squared plus 11 squared, that should be 317. And on the other side, 16 squared should be 256. Now those are not equal. That does not work. So no, this is not a tangent line to the circle. Okay. Alright, so let's look at a few examples where JK is a tangent line. Okay, so we're going to find X. So it's already been proven. It tells us that this is a tangent line. So at the point of tangency is going to be your 90-degree angle, which is J in this case. Okay, so this side should be C. I'm going to label A and B, and we're going to continue doing Pythagorean theorem. This time we're just going to solve. So I'm going to have 7 squared plus 19 squared equals X squared. Okay. So go ahead and add those. 7 squared plus 19 squared is 410. Now, in order to get rid of the squared, you have to take the square root. So the square root of 410, I'm going to just round to the nearest tenth. That's going to be 20.2. And that's my answer. So for number 4, my point of tangency is here at J. That's where it touches the circle once. Where this line JK touches the circle once anyway. So this is going to be side C. I'm going to name this A and this B. However, I do not know this piece. It's a radius though. And this piece is a radius, so they should be both 11. So this entire piece here should be 18. And now I'm ready to set up. So I'm going to have x squared plus 11 squared equals 18 squared. So this time I'm going to subtract the 11 squared. Type it in exactly as it's written in your calculator. 18 squared minus 11 squared. It's 203. Take the square root, and you're going to end up with 14.2. Okay, let's look at number 5. Okay, so on number 5, here's my point of tangency, so here's my right angle. So this side is going to be C, and this side A, and this side B. Now because part of this side C is x, I'm not going to worry about x right now. I'm just going to find C. So that's what I'm going to plug into my equation. I'm not going to worry about the x since it's a part of that side. So I'm going to take 24 squared plus 10 squared, and I'm just going to set it equal to C squared. I'm going to go ahead and solve for C. I'll solve for the whole thing and then I'll find out what just that part x is. So 24 squared plus 10 squared is going to give me 676. And that's C squared. So take the square root, and you get 26 as the whole thing here. Now, x is a part of that 26, but it's only just a piece of it. So let's find out what this other piece is. That's a radius, and so is this piece. This piece is 10. So if I take 26 and I take away 10, that will leave me with what just x is, which is 16. Okay, it's much easier to solve it that way than any other way. Okay. All right, let's look at number 6. Here is my 90-degree angle at J. This is my C. I'm going to name this side A and this side B. Now, A only gives me part of it. This is 11. Now that's a radius. The whole thing is a diameter. So altogether, it should be 22. So I'm going to have 22 squared plus x squared equals 25 squared. Okay, I've set it up. I'll have you solve it later. Let's go on to number 8. Let's skip number 7 for now. Let's go on to number 8. So on number 8, here is my 90-degree angle. Here's my C. I'm going to call this my A and this my B. Now, since part of this side has an x in it, I'm just going to find A first, and then I'll take care of it later. So I'm going to have A squared plus 7 squared equals 25 squared. Okay, I'm going to subtract my 7 squared. So 25 squared minus 7 squared is 576. I'm going to take the square root. And you get A is 24. So if the whole thing here, the whole diameter is 24, x would just be the radius. It would just be half of it. So x is going to be 12. Okay. Give you a few minutes to catch up if you need to write anything down. And we're going to flip it over and we're going to look at the back. Okay. So there will be a problem though, like number 9, where this one's a little bit more difficult, okay? So let's look at number 9. J would be my point of tangency, it would be my 90-degree angle. So this side is going to be C. I'm going to name this A and this B. Now, a part of C is missing, this piece right here. This is the radius. Well, LJ is the radius as well, and it's X. So this piece is X as well. So total, this whole piece is X and it's 10 together. So it's actually X plus 10. So let's go ahead and plug these values into our Pythagorean theorem. A is X, we said, so X squared, plus B is 20 squared. And that's going to equal C, which is total, the X plus the 10 squared. I have to put it in parentheses because it's more than one value. So you actually have to square this out. But it's not just X squared plus 10 squared. It's X plus 10 times another X plus 10. So I'm going to write that up here. X plus 10 times another X plus 10. That's what X plus 10 squared is. Okay, so I don't know if you remember, but there's a process called FOIL, and you have to use that here. Okay, I'm going to write that out to the side. FOIL stands for first, outer, inner, last. It's the order in which you multiply. So if you start with the first two, X times X will give you X squared. If you start with the then you are going to go to the outer. X times 10 will give you 10X. Then you're going to go to the inner. You're going to have 10 times X, which is 10X. And you're going to go to the last. 10 times 10 is 100. Now you're going to clean that up a little bit and combine your like terms. You'd have X squared plus 20X plus 100. Okay, that's what X plus 10 squared actually is. So you're going to replace that. You're going to have X squared plus 20 squared, which is 400, equals X squared plus 20X plus 100. Now we can start to solve. So what happens when you have an X squared on either side of the equation and you go to get rid of one? You should have said they both cancel out. So X squared and X squared will cancel out. So what you will have left is 400 equals 20X plus 100. Now that is something that we can easily solve. Move the 100 over by subtracting and divide. So X is going to be 15. Now that one's the hardest problem you're going to see, but it's really not that bad. I promise. So make sure you have all of that written. I'm going to give you a few minutes to make sure you have all of it written, because there will be a problem like that on your homework that you'll see a little bit later. You'll do the homework tomorrow. Okay, so there's a couple more properties of tangent lines that we're going to look at. The first one here, if two segments from the same external point are tangent to a circle, then they are congruent. So if they're both tangent to the circle and they meet at a point, they're going to be congruent. So they're going to be the same measure. Okay? Same kind of deal here. If a polygon is circumscribed around a circle, then all sides are tangent. So what that means is you actually have these two lines, they meet at the same point, they will be congruent to each other. These two lines that meet at the same point here, they're going to be congruent to each other. And same with these two lines that meet at C. They'll be congruent to each other as well. Okay, so I mark my picture there. So let's look at some examples of this then. So on number 10, These lines, they meet at the same point, so they will be congruent. You're just going to take those equations and set them equal to each other. And you're going to solve for x. That's all you're doing on that one. I'm going to let you solve for x on that. I'll help you set these problems up. So on number 11, these 2 points, they meet at the same point. They're going to be congruent. I'll let you figure that one out. So in number 12, let's look at number 12. We're going to try to find this segment here, SV. But I do know that these two are congruent since they meet at the same point. So I'm going to go ahead and solve for that. 10x minus 41 equals 4x plus 7. So let's go ahead and solve for x by moving the 4x over first. I'm going to add the 41 over. And I'm going to divide. So I got what x is. And I want this piece right here. So if you pay attention, these are tangent lines where 90-degree angles are formed right here. If I plug it in, I'd have 2 of the sides of a right triangle. I could use Pythagorean theorem to find the third. So I'm going to plug it in. 10 times 8 minus 41. It's going to give me 39. And this side will be C. I'm going to name this A and this B. So I'm going to take 39 squared plus 17 squared equals C squared. So if I take and add those, 39 squared plus 17 squared, so 1,810. And then I want to take the square root. And that would be 42.5. Okay, last couple problems. We want to find the perimeter of this triangle. I'm going to start by marking which sides are congruent. So DG and DH, they meet at the same point, they will be congruent. They're both going to be 11. HE and EI, they meet at E, they're going to be congruent. And GF and IF, they meet at F, they're going to be congruent. So all I'm going to do is take all of these numbers and add them together. 11 plus 11 plus 16 plus 16 plus 9.5 plus another 9.5. So my perimeter should be 73. Okay. We want to find the perimeter of this quadrilateral. So this piece right here, 23, should be the same as this piece. Both pieces around P should be 23. But in order to find the pieces around Q, I want to take this whole value, the 37.5, and take away the 23 that I just found. Right here, I want to take away this piece. And that will leave me with 14.5 for either side there. Okay. Now I know the two pieces around R are both 27.1. So if I take that 27.1 away from the 52.5, that will leave me with the pieces around S, which are 25.4. So now I'm going to total up the top and the bottom, 37.5 plus 52.5, and then I'm going to add the sides, 23 and 25.4 and 14.5 and 27.1 to give me the perimeter of 167. I did something wrong, hang on. Let me make sure that I added up total. 37.5 plus 52.5 plus 23 plus 25.4 plus 14.5, that's where I went wrong, plus 27.1. Should get 180. Sorry about that. So finish up these problems. Then you have an activity, the tangent lines find someone who. You can work that individually, or you can work it as the directions read. Just make sure that you are quiet and working no matter what you choose.